Greetings, this is Unit 5, Module 1, Session 4. The name of this home connection is Angles and Rectangles. It's a two-pager. Put your name and number at the top so you can get credit for the work that you are doing. Let's begin. Alexis put two 90-degree angles together to make a new angle. How many degrees does the new angle measure? So we have 90 degrees times 2. So you're going to double 90. You could do it a couple different ways, right? 90 plus 90, you could add it. Or you could stack it and use the standard algorithm. Regardless, you are going to get 180 degrees. The fun part about this, and I do have most of my shapes put together here, is that if I took my pattern blocks and I put two 90s together, because we know squares have four 90-degree angles on the inside. I put two of them together. So let's say I kind of draw just the outline here. And we'll do a little tick mark here to show that that's where they meet. So on these two squares that I put side by side, I have a 90 here, a 90 here, 90 and 90 gives me 180 degrees. Now, what do I make from that? It says, what kind of angle did Alexis make? Fill in the bubble to show. Well, I took this 90, I put this 90 next to it. 90 plus 90 is 180 degrees. Well, which only one of these choices says exactly 180 degrees. And if you notice, that is a straight angle. So that's our choice. The fun part about having the pattern blocks nearby is that you can visualize it. Maybe this 90 plus this 90 gives us that flat line right across the bottom. So that's our straight angle, exactly 180 degrees. Henry put three 45-degree angles together to make a new angle. How many degrees does the new angle measure? Well, this is going to be kind of interesting, I guess. So 45 times 3. If you can do it in your head, great. But if not, you could take 45 times 3 and do it this way. Or you could take 45 and add it 3 times. You're going to get the same answer no matter what, but let's do the algorithm on the left. And maybe I'll zoom in just a little pinch. 5 times 3 is 15, carry the 1. 4 times 3 is 12, plus 1 is 13. So our answer is 135. It says, what kind of angle did Henry make? Well, what do we know about these? I have the definitions up here. Acutes are less than 90. Right angles are exactly 90. So what do we have? That's 135. So it can't be acute. No, can't be that. Right angles are exactly 90. That's not exactly 90. It can't be that. Obtuse angle more than 90 but less than 180. Yeah, there we go. That is more than 90 but less than 180. Okay? And if you're thinking, well, it might be dangerous to think like me, but I'm going to do it anyway. So what if I put 4 pattern blocks together and I do kind of a rough square here? I know it's kind of dangerous to do this sort of thing, but I just like to visualize. Ooh, and I like to be precise, but that's proving to be challenging. So I decide to outline, my 4 squares, which I sort of did. I can use my protractor to fix this, though. Okay, so there's my square, and then we had this business here. So let me connect these in the middle so that we can see how the squares fit, and hopefully this will make sense very soon. If I started up here, maybe at 0 degrees, I would do 45, 45, and another 45. So this is my angle right here that I'm measuring, my 135 degrees. And that, as you can see, is more than 90. Here's my 90-degree angle here, but it's less than a straight angle too. So that is an obtuse angle. Ooh, Austin put 4 15-degree angles together to make a new angle. How many degrees does the new angle measure? They gave you the formula, 15 degrees times 4. 5 times 4 is 20, carry the 2. 4 times 1 is 4, plus 2 is 6. So we have a 60-degree angle. Ooh, I forgot my degree up here. Don't forget that. 60-degree angle if you put all of them together. What kind of angle did we make? Okay, well, it says a straight angle is exactly 180 degrees. 60 is not exactly 180. An obtuse angle, according to this, is more than 90, less than 180. Nope. Right angle is exactly 90. No, this is exactly 60. It cannot be a right angle. And that means we only have one choice, but let's check the definition. Acute angle is less than 90. 60 is less than 90. So it is, oh, such a cute angle. And I'm sorry that my paper's bouncing around, but it's so nice that they put the definitions in that first question, in case you want to refer back to it. Claudia drew and labeled a rectangle. Here's a miniature picture of her rectangle, and we're going to be using this diagram to answer these questions down here. What is the sum of the 4 interior angles in Claudia's rectangle? What is an interior angle? So if you have a shape, it could be a rectangle like you see. It could be a triangle. It could be a hexagon. It doesn't matter what the shape is. The interior angles are the angles on the inside, the interior. So here's an interior angle, here's an interior angle, here, and here. Those are all interior angles. A square or a rectangle has 4 sides, so it has to have 4 angles. Whereas this triangle, if I quickly sketch it, which sometimes takes me a while, but I'll kind of rough it out here as fast as I can, has 3 sides, and it has 3 interior angles, the angles on the inside of the shape. You can probably guess, without thinking too hard, about how many angles this hexagon has. The hexagon has 6 sides, so how many angles does it have? 1, 2, 3, 4, 5, 6 angles. Okay? So it says, what is the sum of the 4 interior angles of the rectangle? We know that all rectangles and squares are made up of right angles. So we know that all of these angles are precisely right angles, or else they wouldn't be squares and rectangles. They would be another shape. Okay? What does it say about right angles? Right angles are exactly 90 degrees. So every one of these interior angles is 90 degrees. And I am going to let you add all of them up and answer this question. The perimeter of Claudia's rectangle is the distance around the rectangle. Perimeter is adding up all the sides. And since this is a rectangle, opposite sides should match. Let me change colors. Opposite sides should match. You're going to add up all 4 sides to get the perimeter. Make sure you answer it in centimeters, please. What is the area of Claudia's rectangle? Well, don't forget, area equals how tall it is, or we could say the height, times the width. How tall it is times how wide it is. How tall it is times how wide it is. Well, and that's a 2x2 algorithm, so that's going to be good practice. Oh, I feel like I should do that one with you. I'm just going to do it with you. You're going to have to remember the 0, so let's just do it. I'll zoom in a little bit more. If we do 43 times 37, start with the 7. 7 times 3, 21, carry the 2. 7 times 4, 28, plus 2 is 30. The next line starts with a 0. 3 times, and that's the part that I wanted you to remember. 3 times 3 is 9. 3 times 4 is 12. And then you're going to add to get your answer. Okay? You can handle that step without me. Don't forget the 0. Don't forget the 0. Claudia colored half of her rectangle blue. What is the area of the blue part of the rectangle? Show your work. Couple ways to do this, but if you would allow me, honest to goodness, I think you would be better off if you took the answer here And whatever that answer is, and you divide it, cut it in half. If you have half the rectangle, you have half the area. Okay? If you really wanted to, you could draw a line here and maybe have 21.5, which is a hard number to multiply times. Or you could draw a line that way and have, what would that be? So 16, so it'd be 18.5. And that's also a hard number to multiply by. So I really think you would be better off trying to figure out what half of this answer is. Okay? My suggestion. But I am going to let you do that one on your own. If you need help, ask a math wizard. They will take good care of you. Your teachers love to answer math questions. We love math. Math is math. It's so good. Check you later.